Here we are going to see the question from signals and system given in GATE 2007. So given that here we need to find the 3 dB bandwidth of the low pass signal e power minus t u of t, where u of t is the unit step function. So here by finding the 3 dB bandwidth, we'll get it as option A as the answer. So given that the low pass signal, come into the solution, given that the low pass signal x of t equals to e power minus t u of t. So here, in order to find the 3 dB bandwidth, we need to convert this x of t from time domain to frequency domain, and by drawing the magnitude spectrum we'll find the 3 dB bandwidth. So by applying the Fourier transform for this given x of t, and by taking the magnitude for that x of Fourier transform of x of t represented with x of omega, we will get this is a low pass filter, so we will get the magnitude spectrum like this, and the maximum value is 1 here, and at 3 dB point representing this as omega on x-axis, and the 3 dB point at omega 1 is 1 by root 2 the amplitude. We know that at 3 dB point we have the amplitude of 1 by root 2, magnitude as 1 by root 2. Then the 3 dB bandwidth is nothing but omega 1 minus the initial value of the frequency 0, then this is equals to omega 1 only. That is the 3 dB bandwidth. Now we are going to find the Fourier transform for this x of t. After that we are going to find the magnitude, and by making equals that magnitude equals to 1 by root 2, then we will get the omega 1 value, that becomes the 3 dB bandwidth. So apply the Fourier transform for this. So x of omega equals to Fourier transform of x of t, that is, we know that for e power minus a t u of t, the Fourier transform is 1 by a plus j omega, and here this is e power minus t, so a value is 1 here, so this is 1 by 1 plus j omega, calculating the magnitude here, mod x of omega equals to, this is 1 by square root of 1 plus omega square. Now we need the omega 1, so at omega equals to omega 1, we have mod x of omega equals to 1 by root 2. So by substituting in this equation 1 at omega equals to omega 1, then we'll get this is equals to 1 by root 2 equals to 1 by square root of 1 plus omega 1 square. So this is equals to square root of 1 plus omega 1 square is equals to root 2. Then cancelling the square root on both the sides, then this becomes equals to mod 1 plus omega 1 square equals to 1 plus omega 1 square equals to 2, then omega 1 square equals to 1, then omega 1 equals to 1. That's what we will get, omega 1 equals to 1. So here the answers are given in terms of hedges. given in terms of hedges. Now we need to convert these angular frequencies into hedges. Then we know that 2 pi f1 equals to 1, f1 equals to 1 by 2 pi hedges. That's what the answer, 1 by 2 pi hedges.